Dear students, today we are going to enter into carbonyl compounds. Already in organic chemistry we have covered hydroxy derivatives and ethers. Now one step ahead, carbonyl compounds. Compounds which are having carbonyl group in them are said to be carbonyl compounds. They should possess C double bond O. Valency of carbon is 4, 1, 2, 3, 4. At one side, if we have H, we call it as an aldehyde. If we have both sides alkyl group, it is said to be a ketone. Carbonyl groups attached to two alkyl groups are said to be ketones. If at least in one side you have hydrogen, it is said to be an aldehyde. At least one hydrogen. So those carbonyl compounds we are going to see. There are so many important carbonyl compounds are available. So many. And among them pyridoxal, an important compound derived from vitamin B. Pyridoxal. Vitamin B, it may be considered as vitamin B6. Of course, structure we don't need. We should know it is derived from pyridoxal, is derived from vitamin B. And it may be a component of vitamin B6 that you can know. And it is pyridine. Basically, it is pyridine. That's why it gets the name pyridoxal. Pyridine. What is pyridine? CH, 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 N. This is pyridine. That you have studied already under heterocyclic compounds. Valency of nitrogen 3, that of carbon 4. Molecular formula C5H5N. This is the molecular formula for pyridine. You have seen already other heterocyclic compounds. The derivative of pyridine is pyridoxal. It has got one methyl group here. I can simply write like this. A hydroxyl group here. A carbonyl group C double bond O. I can write like this. C double bond O group here, and then a methyl alcohol group CH2OH can be written like this. So it is pyridoxal. Pyridine containing hydroxyl groups, an aldehyde group C double bond O, carbonyl group. It is of course a ketone CO, this side alkyl, and then a methyl group. This is pyridoxal. Shall we try the IUPAC name? It starts from here. 1. We have branch here, OH here and here, but if we start from here, it may be better because we have one more branch here. 1, 2, 3, 4, 5, 6. We have hydroxyl group at third carbon atom, therefore 3 hydroxy. One more hydroxy we have at fifth carbon, but it's not simply hydroxy, it is hydroxy methyl. CS3OH means methanol, and one hydrogen is attached here, therefore it can be called as 5 hydroxy methanol. Hydroxy methyl, not methanol, hydroxy methyl. 5 hydroxy methyl. And then at the second carbon atom we have a methyl, 2 methyl. Just to make you to get interest over the subject, I have introduced the name. We don't need this IUPAC name. Just to give you an exposure, I tried. At the third carbon we have OH. Numbering we start from here. What for? It should get priority. It will get priority, but it is at the fourth carbon atom. Instead of trying this side, this side is better because it has got OH as well as a methyl group. 3 hydroxy. It is arranged in alphabetical order. Hydroxy, hydroxy methyl, methyl, like as it goes. Hydroxy, hydroxy methyl, methyl, and then we have the basic compound. What is it? Pyridine. 5 hydroxymethyl, 2 methyl, and then we have pyridine. 2 methyl pyridine, basic compound. 2 methyl pyridine. And then what else we have? This carbaldehyde. So C double bond O, and then we have H. It is an aldehyde functional group, not ketone, aldehyde functional group. C double bond O will be having H. Then only valency will be satisfied. Alright. So the structure may be, instead of this hydrogen we have methyl, instead of this hydrogen we have OH, instead of this hydrogen we have CH2OH, and here we have C double bond OH aldehyde. So we end with aldehyde, carbaldehyde, pyridine carbaldehyde. So everything should go continuously. Everything should go continuously. All right. 3 hydroxy, 4 hydroxymethyl, 2 methyl, pyridine. That is one pyridine. At the first carbon atom we have nitrogen, and that need not be mentioned. All right. 4 carbaldehyde. This is how the name goes for pyridoxal. It is derived from vitamin B. It has got carbonyl group, aldehyde group. Since it happens to be a vitamin, derivative from vitamin, it happens to be an important organic compound. Likewise, formaldehyde when combined with phenol, it is formaldehyde, when made to react with phenol, we get a polymer wherein both the ortho position and at para position, the CH2 group will be bonded. You will be getting the compound benzene ring, OH, CH2, bond CH2. Likewise it goes CH2, CH2. The extension, formaldehyde contents here, get contents here, get contents here, the polymer you will be getting. So this is known as bakelite, thermosetting plastic. Alright. In that also, the formaldehyde is involved in the preparation of bakelite. And then paracetamol, para-acetamidophenol. We'll be having benzene ring, OH, phenol, para-acetamido, NH, CO, CS3. CO, CS3, NH2 is acetamide. That acetamide is present at para position. Para-acetamidophenol is known as paracetamol. Paracetamol, we call it as paracetamol. It is the main drug used as an antipyretic. Whenever we feel feverish, when the body temperature goes high, we use what is called paracetamol. All right, and it can be, it is a carbonyl compound. Carbonyl compound. So carbonyl compounds are used in so many things, and those carbonyl compounds, just to show the importance I have shown. Otherwise, you need not know the structure now. You need not know the structure now. If you go for medicine, you may have to learn these structures and structural isolation. All those things you will be learning later on. Now, you should know carbonyl compounds are important. Now, let us go into naming of carbonyl compounds, especially naming of aldehydes and ketones. So, in this chapter, we are going to concentrate carbonyl aldehydes and ketones first, followed by carboxylic acids, esters, amides, etc. All right. Now, very simple aldehyde. What is an aldehyde? As I said, CHO, if it has CHO functional group, we call it as an aldehyde. C double bond OH. Simply it is written as CHO. That doesn't mean it is CHO. It is not CHO. Don't think that it is CHO. Valency for hydrogen is only 1. Valency for oxygen is 2. Valency for carbon is 4. Nothing is fulfilled. So the structurally aldehyde is C double bond OH. With that, if alkyl group is added, we call it as an aldehyde. Very simple aldehyde may have, instead of alkyl, it may have hydrogen. That we call HCHO. HCHO. Elaborate structure may be H, C double bond OH. All right. What is the common name? Common name for the compound is formaldehyde. The name is derived from formica. Formica means redant. From the venom of redans, we get formic acid. Corresponding acid we are getting. Similar aldehyde, therefore formaldehyde. It gets the common name derived from formic acid, formica, and the name is formaldehyde. And IUPAC name may be methanol. Methanol, one carbon atom, One carbon atom, methane. Just if we have only one carbon atom with the 4 hydrogen atoms, we call it as methane. Here, with one carbon atom, we have aldehyde. Double bond. Instead of 2 hydrogen, we have aldehyde. Therefore, aldehyde should end with the suffix Al. Methane. Instead of E, we add the suffix Al. Al suffix is added. Whenever vowel letter starts as a suffix, E has to be eliminated. Therefore, methanol. Alright. When we go for one more increase in number of carbon atoms, CH3, CHO, we call it as acetaldehyde. Because CH3COH is acetic acid, corresponding aldehyde acetic acid. But IUPAC name, 2 carbon atom, therefore ethane, ethanol. Alkane, eth for 2, alkane, ethane. But we have aldehyde substituent, therefore E is replaced by Al. And then next one, propionaldehyde. It is corresponding acid, propionic acid, therefore propionaldehyde. I didn't write the elaborate structure that you may be knowing. Propionaldehyde is the common name. But IUPAC name, IUPAC, propane, instead of E, Al, propanol, that's all. Propanol. Here we have substituted aldehyde. We have one substitution, hydroxy substituent. 1, 2, 3, 4. The common name is aldol because it is the combination of 2 aldehyde molecules. It is considered as aldol. IUPAC name will be, at the 3rd carbon atom we have hydroxy group. Basically, an aldehyde containing 4 carbon atoms. 4 carbon means meth, eth, prop, butane. Aldehyde functional group, therefore butanol. At the 3rd carbon atom we have OH, therefore 3-hydroxybutanol. Common name aldol. Of course, common name for everything we need not write. CH2 double bond CH-CHO. It is an unsaturated aldehyde. It is called as acrolein. Common name acrolein. Acrylic aldehyde. It can be called as acrylic aldehyde. IUPAC name will be 1, 2, 3. The aldehyde should get priority. Therefore, number 1. Totally 3 carbon atom, therefore prop. It is not ane. It is not a saturated hydrocarbon, unsaturation, a double bond. Therefore, it should end with ene, propene. The ene starts at the 2nd carbon atom. Therefore, proptoene. And we have aldehyde functional group. Therefore, Al suffix should be present. Proptoenal. Propinal. Alright. No other option available. Even 2 is not necessary here because in no other place we can have double bond. Next compound. 1, 2, 3, 4. It is crotonaldehyde. What may be the name? Can you guess? 4 carbon atoms, bute. 2nd carbon atom, double bond, butene. Aldehyde at the first, you should get priority, Al. Butanol. Alright. Now what is it? This compound you might have seen in glycerol. Glycerol structure we have written like this: CH2OH, bond to CHOH, bond to CH2OH. It is glycerol. Is it not? That you might have seen already, glycerol. If it is oxidized, what is the meaning of oxidation? Removal of hydrogen or addition of oxygen. Here removal of hydrogen, CH2OH. Two hydrogen atoms are removed. Therefore, a double bond. It becomes aldehyde. It becomes CHO. CHO, CHOH, CH2OH. That's it. CH2OH, CHOH, CHO. Both are same. It is called as glyceraldehyde. Glycerol, upon oxidation, produced glyceraldehyde. That is common name. What about IUPAC name? 1, 2, 3. 1, 2, 3. At the third carbon, we have OH. Second carbon atom also we have OH. So basically it is propane. Basically it is propane and then all propanol. Propanol. At the second and third carbon we have OH. Therefore 2,3-dihydroxy. 2,3-dihydroxy. 2,3-dihydroxy propanol. Alright. That is the IUPAC name. So we have seen few aldehydes. One more aldehyde. What is it? Let me write about this aldehyde. Benzene ring with that a CHO group. It is called as benzaldehyde. Benzaldehyde. C6H5CH is benzol. C6H5 phenyl. C6H5CH2 benzyl. C6H5CH benzol. C6H5C benzo. Phenyl, benzyl, benzol, benzo. Now we have C6H5CH, but it happens to be an aldehyde, benzaldehyde. That's all. Benzaldehyde. IUPAC, it is IUPAC accepted common name. So IUPAC name may also be considered as benzaldehyde. Nothing wrong in calling the compound as benzaldehyde. It may also get the name phenyl methanol, because it is methanol. Instead of a hydrogen we have phenyl. Phenyl methanol can be called. Phenyl methanol can be considered as derivative of methanol. But we usually call it as benzaldehyde only. We don't go in for phenyl methanol. So that is about IUPAC names for few compounds. Alright. So until now we have seen only aldehydes. Benzaldehyde, preferable IUPAC name may be phenyl methanol as well as benzol. Commonly we use benzaldehyde only. Nothing wrong in using phenyl methanol. Now let us go into few ketones. For all these ketones we are going to assign IUPAC names. The simplest ketone, the first member is the simplest ketone. CS3, CO, CS3, simplest ketone. Carbonyl group bonded with two alkyl groups. Just a 3 carbon, it is a common name acetone. Acetone. CS3, COOH is acetic acid. CS3, CHO acetaldehyde. CS3, CO, CS3 acetone. May be called as dimethyl ketone also. Dimethyl ketone. Ketone at both sides we have methyl group, therefore dimethyl ketone. Both are common names. Dimethyl, it is ketone, C double bond O. C double bond O, at both sides we have methyl. Propanone. Propanone. Alright. Next one. CS3, CH2, CO, CS3. We have 4 carbon atoms. A ketone with 4 carbon atoms, 1, 2, 3, 4. Numbering should be from here. Why? The carbon group should get the lowest number. And therefore, butane. If it is CH2, it can be called as butane. But at the second carbon atom, we have ketone, one. Therefore, butane, one. ONE. That one is at the second carbon atom. Always it will be at the second carbon atom only. Nothing wrong in simply mentioning butanone, or we can also say butane 2-1. No other one is possible. If I write CO here, it will be 2-butanone. Therefore, It can be simply butanone or butane 2,1. What about common name? Methyl at one side, ethyl at another side. Ethyl methyl ketone. Ethyl methyl ketone. An alkyl group with 2 carbon atoms, ethyl, an alkyl group with 1 carbon atom, methyl, EM. These 2 alkyl groups have to be arranged in alphabetical order, therefore ethyl methyl ketone. That is common name. What about this one? Acetone, and then 2 acetone molecules get fused. It can be elaborately written as CS3, CCS3, double bond, CH, CO, CS3. Numbering should start from here 1, 2, 3, 4, 5. At the 4th carbon atom we have methyl. Therefore 4 methyl. At the 4th carbon atom methyl substituent. Therefore 4 methyl. Totally 1, 2, 3, 4, 5. 5 carbon atom. Therefore pent. It has got ene. That ene starts at 3rd carbon atom. Therefore pent 3 ene. 4th carbon atom methyl branch. Totally 5 carbon atoms pent. At the 3rd carbon double bond, and at 2nd carbon atom O ketone. Therefore 3 ene 2 on. O is vowel letter, therefore E can be eliminated. 4 methyl pent 3 ene on, 3 ene 2 on, pentenone, 4 methyl pentenone. Alright, and the common name is mesityl oxide. Mesityl oxide. This compound we are getting when 2 acetone molecules get fused. CS3 CO CS3, CS3 CO CS3, CS3 CO CS3, CS3 CO CS3. These are the 2 acetone molecules. When they get fused, removal of water, H2O, a double bond. This is the compound, mesityl oxide. When 3 molecules of acetone get combined, CS3 C double bond O, CS3 CO CS3 plus CS3 C double bond O CS3. Here 3 acetone molecules, H2O, here one H2O, we get double bond here, we get double bond here. It is said to be 4 on. Let me write the structure and let us try to assign IUPAC name for this compound. CS3 twice C double bond CH, sorry, C double bond CO, C double bond CS3 C double bond CH, CO, CH double bond C, CS3 twice. CS3 C, yes. This is called 4 on. 4 on. The structure CS3, CS3, CH double bond CH, CO, CH double bond C, CS3, CS3. 1, 2, 3, 4, 5, 6, 7. Totally 7 carbon atoms in the longest chain. At the 2 and 6th position, 2nd and 6th position, we have methyl. Therefore 2,6-dimethyl. 2,6-dimethyl. 2 methyl, therefore dimethyl. At the 2nd carbon atom 1 methyl, 6th carbon atom 1 methyl, 2,6-dimethyl. Hept. Totally 7 carbon atom, therefore hept. Hept. Ene. Not a single ene, double ene. Therefore diene. At the 2nd carbon atom and the 5th carbon atom. Therefore hept 2,3 diene. Hept. Totally 6 carbon atom, therefore hept. Ene at the 2nd and the 6th and the 5th. Therefore diene. Hept 2,3 diene. 2,5 diene. 2,5 diene. And we have one at 4th carbon atom. Therefore hept 2,6-dimethyl, hept 2,5-diene, 4 on. 4 on. This 4 on is written like as common name 4 on. 4 on, 4 on. This is how it gets the name. Alright. And then CCH5, COCH3. The common name for this compound is methyl phenyl ketone, MP. M first, P next. Therefore, methyl phenyl ketone. Methyl phenyl ketone. It may also be called as acetophenone, both common as well as IUPAC. Acetyl phenyl, acetophenyl, but ketone, acetophenone. Acetophenone. The same acetophenone may be considered as IUPAC name also. Acetophenone, IUPAC accepted common name. Sometimes common name will be accepted by IUPAC. Therefore, acetophenone is IUPAC accepted common name. But we can assign one more name. What is it? 1, 2. Basically, it is ethane. Phenyl substituent. 1 phenyl. Ethanone. At the first carbon atom. 1 phenyl, 1 ethanone. Ethanone. That's all. It can also get the name 1 phenyl ethanone. At the first carbon atom phenyl. Therefore, 1 phenyl ethanone. And then next compound. Let me rub this. CH3, CH2, C double bond O, CH2, CHO. What is the IUPAC name? 1, 2, 3, 4, 5. Totally 5 carbon atoms. Therefore, meth, eth, prop, but, pent. Here we have ketone as well as aldehyde. There we got a little bit confusion. Whether it has to be end with one or AL. One AL, AL one meaningless. Pental one, pentonal, likewise it won't come. In such situations, the carbonyl group gets the name oxo. So we give pent 3-oxopentanal. 3-oxo, the third carbon atom we have oxo, 3-oxo substituent, 3-oxopentanal. 3-oxopentanal. All right. So this is how it gets the name for this compound. 1, 2, 3, 4, 5. At the third carbon atom, 3-oxopentanal. Pentanal at the AL is at the first carbon atom. And then next compound, 3-oxopentanal. All right, this compound is good. We have aldehyde functional group as well as COH group at adjacent carbon atoms. All right. It may get the name formyl substituent. Here also all ALic acid cannot come together. It is aldehyde, therefore it should end with the suffix Al. COH, therefore it should come with the substituent ic acid. ALic acid cannot come. And therefore, just like here, the ketone is getting the name oxo, likewise it gets the name formyl group is substituted. 1, 2, at the second carbon atom, formyl group is substituted, and it is phenyl methanoic acid or benzoic acid. 2 formyl, phenyl methanoic acid. At the second carbon, we have formyl group, therefore, it gets the name 2-formyl phenyl methanoic acid or 2-formyl benzoic acid. If we remove this, it can be called as benzoic acid or phenyl methanoic acid. At the second carbon atom we have formyl. Therefore, 2-formyl benzoic acid. This is the most accepted IUPAC name, phenyl formic acid. Nothing wrong in saying 2-formyl phenyl methanoic acid. And then five-membered ring. It is a 5-membered ring, double bond, methyl a ketone group. It should get priority. This should get number 1. This should get number 1. 1, 2. Number 1 carbon, 2, 3, 4, 5, like this it goes. So what may be the name? At the third carbon atom we have a substituent methyl, 3-methyl. It is a ring structure, therefore cyclo. 3-methyl cyclo. 5 carbon atoms, pentane, but not pentane, it is ene. How many enes we have? At the second carbon atom we have double bond, at the fourth carbon atom double bonds. Double bond starts at second carbon atom, double bond starts at fourth carbon atom. 2, 3, 4, 5. Therefore 2, 4 we have to consider. So 3-methyl cyclopen 2,4-diene. 2,4-diene. Sorry, 2,4, 2,4-diene. It is a ketone, dienone, that's all. Dienone or 1,1. 3-methyl cyclopen 2,4-dienone. So this is how, if we try a little bit, it is possible for us to assign IUPAC names for almost all the compounds. For few compounds we may not be knowing common names. Alright. Now few more examples as given evaluate yourself. 1,1 is not needed. Diene 1,1 is not needed. If needed, you can write 1,1. That is not needed. Then few questions are given under evaluate yourself. Let me discuss those questions also, so that we'll be having complete idea over assigning IUPAC names. All right. So first compound, benzene ring is given with alternate single and double bonds, a methyl group, and then CHO. All right. Then second compound, CH3 twice, that is CS3, CCS3, double bond CH, COCS3. This compound we have seen, this is this one. For this we have seen already, no need to repeat. CS3 twice, COH, CH2, CHO, another compound is given. Then one more compound, line structure is given. This is the first one, second one, third one, fourth one. For these compounds you are asked to write IUPAC names. So let us try IUPAC names for these compounds. It is benzaldehyde, phenyl methanol. At the fourth carbon atom we have methyl. Therefore 4-methyl benzaldehyde. That's all, very simple. 4-methyl benzaldehyde. Nothing wrong in saying 4-methyl phenyl methanol, but better benzaldehyde. Benzaldehyde, IUPAC accepted. 4-methyl benzaldehyde. What about next one? 1, 2, 3, 4, 5. Totally 5 carbon atoms. At the fourth carbon atom we have methyl. Therefore 4-methyl. We have assigned the name already. 4-methyl ene at the third carbon atom, pentathiene. 4-methyl pentathiene 2,1. pent 3 enone. That's all. What about this one? Third one. Let us try third one. After that, let us go in for fourth one. Let me rub. Continue. Third one I am going to try now. Let me write the elaborate structure. What can be the elaborate structure? CS3, CH, CS3, CH2, CH. I think it is a double bond. There is a double bond. Yes, double bond. Therefore, it cannot be CS3, double bond, CH, C double bond O, CS3. This is the structure. Am I correct? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Double bond over second carbon atom, third, fourth carbon atom, a methyl group. Sixth carbon atom, another methyl group. There is a double bond here. Therefore, valency 1, 2, 3, 4 balanced. Valency 1, 2, 3, 1 with hydrogen balanced. Numbering should be from here because the ketone should get priority. What are the substituents? Fourth carbon atom methyl, sixth carbon atom methyl, 4,6 dimethyl, 4,6 dimethyl, not simply methyl, dimethyl, 4,6 dimethyl. Hept, totally 7 carbon atom, therefore hept. Third carbon atom ene, hept 3 ene. And at the second carbon atom we have 1. So 4,6 dimethyl, hept 3 in 2 1. That's all. 4,6 dimethyl, heptene, that is 3 in 2 1. Now, fourth, last one. Let me go to the last compound, fourth compound. What is it? CS3, 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 CS3. With the same carbon OH, so I may write CS3 above and OH I can write at the bottom. With the C, a OH, with C2 methyl, with C2 methyl and OH. With the same C, CH2. CH2. That you should understand. Alright. What about IUPAC name? 1, 2, 3, 4. Priority to aldehyde. Totally 4 carbon atoms, but at the third carbon atom we have hydroxy substituent. At third carbon atom we have methyl substituent. Hydroxy first, methyl next. 3 hydroxy, 3 methyl. Totally 4 carbon atoms. But. Only saturated, butane. Aldehyde the first carbon atom, Al, butanol, enough. 1 Al, nothing wrong. Butanol or butane 1L. One is understood, therefore I didn't mention. So that is about assigning IUPAC names for different compounds. I hope you understood IUPAC names. Next, let us go into the next level of understanding. We should understand about the structure of carbonyl compounds, preparation, properties, uses. Usually, in the chapter, we will be saying preparation, properties, uses. Regarding the structure, you should have thorough understanding, then only reactions you can understand. Thank you.